Today I have a little bit of an update on the caching layer for Trashify. First of all, I changed to Google Maps instead of using a plethora of different services. I'm now just using Google Maps for my location needs. Specifically, the two location needs that I do have are geocoding and reverse geocoding. Geocoding refers to when you give like a service like Google Maps your current place, right? Like I gave it Brampton. You could give like a specific address too, but I give it Brampton. And then once you give this place, you will get the associated longitude and latitude plus different information on it. As you can see, this is my information that I have here. Okay, so that's how geocoding works. Then I'm also using the same URLs, just that within the queries, instead of address, I'm using longitude and latitude. And if you haven't guessed it already, that is reverse geocoding. I'm using reverse geocoding, which does the exact opposite of what geocoding does. You will give it a longitude and latitude, and it will present you a specific place based on that longitude and latitude. Unlike geocoding, where you give it a place and you get the longitude and latitude for that place. In our case over here, I'm doing geocoding because I'm giving it a place and I'm getting a specific longitude and latitude for that place. Alright? Okay, so now that you understand the two things that I use it for, okay, another important thing to understand is why do I need it? Alright, and to best do that, let me just hop into my code base and get started. First thing that I did though within my code base is I actually changed the file which includes all my caching logic into a cache.ts, and then I kept the memcache as just like a configuration for my memcache SDK. This is just so that developers don't get misled and think that the memcache just has a configuration, but in reality before it just had all my caching logic. And this also helps because if I decide to add other cache layers like Redis, I can add it all within the cache.ts. Anyways, above that, I also went ahead and modularized my code into different helper functions, so that this way my code, first of all, can be repurposed and reused, and second of all, it helps with readability, which will help with developer experience. Alright, so now that we've gone through that, alright, if we go into fetch and cache city, essentially we're using this to request to the Google API, alright, as you can see through here with Axios. And then all I'm doing is I'm getting the locality type, so that's within the address components. And then over here you can see that each of these items have a types list or property, I guess, and in that you can have this different types that are available for that specific place or that specific address. Alright, so I'm just iterating over them. As you can see with the find, this is just O of n, right? I'm just iterating, I'm going one after another, and that's because there isn't usually that much address components, and all I'm doing is I'm trying to find locality, which is our city. Alright, as you can see here, and I'm getting the long name. Alright, and over here I'm just throwing a new error if I can't find that city, and hence that's why my promise has the type of error as well. Alright, cool. So now that we know about that, alright, that's what this is doing. And then it's also setting of course it's going to set that locality or that city to the cache, right, through this function. Again, this is why I modularized it, because I use set to cache a lot, right? So I don't have to keep rewriting this logic. I can just use this function, and essentially I'm just caching the city by the key and the value and then expiration. Okay, not too bad. And I'm just returning it, and the reason why I'm returning it is for the first initial use, so that like my main function, which calls it the helper cache city, actually has a city to to do the logic the first time when there is a cache miss. Alright, and you can see all that logic happening here, right? So we're getting the city from the cache, and then if we do not have a city within the cache, we're gonna just first fetch and cache the city, and this function will return the new city. All right, and we're just gonna make sure that that's not the instance of an error, and we're just gonna throw that new city if there is. All right, so if there is an error, we're just gonna throw that new city because that's now an error. If not, we're just gonna set city to new city. All right. Similar logic actually should apply here too, now that I'm thinking about it, because this is also doing about the same thing, right? Yeah. Okay, anyways, so now that we have that city, all right, what we're gonna do is we're actually going to have a new issue, all right? And this issue is that we have the city, okay, and the city is within the cache, okay? So we're avoiding that extra API call and that extra cost for that API call. But now the issue that arises is stale data. And what do I mean by that? Well, what if I move to another city? So we do have an expiration, and if I actually go into Memcache, you'll see that expiration for city, which is an hour, okay? But people can move to another city within an hour. It's realistic. So what if I move to a new city, right, within that hour, and now that we're retrieving from that cache because there's a cache hit instead of a cache miss, we are not. That is stale, right? That's not accurate. I'm not within that city. Okay, I'm in a new city. Well, we're actually going to double check if a user is within a specific city through this following logic. First of all, we actually need to get the bounds, okay, and we get this within the API as well, and this is the reason why we needed to do geocoding. If you didn't notice, over on fetch and cache city, this is actually doing reverse geocoding because we're taking latitude and longitude, all right, and getting the place based off of it. But now we're actually going to be doing geocoding, and the reason for that is because if I go back here, we already know the city that we're in, all right, so all we need is a specific information, and that specific information is within the geometry, okay, this part, and the geometry essentially is has a lot of different properties, but all we need is the bounds. So if I go within the bounds, you'll see that I have a northeast and a southwest property, and what this whole property is doing is it's setting the perimeter for that specific city, okay, by giving it a north coordinate, a east coordinate, a south coordinate, and a west coordinate, all right, and each of these coordinates, or I should say point, actually not coordinates, but each of these points are being defined by either the latitude or the longitude. Okay, so with basic geography knowledge, you'll know that a latitude goes up and down like this. Okay, it goes up and down like this. What also goes up? North. So that means that latitude is associated with the north direction. How about east? All right, east goes like this, right? You're gonna go like this. I think so, at least. But you're gonna go like this, right? You're gonna go on a horizontal plane. What also goes on a horizontal plane? Longitude. So that is associated with east. Same thing with southwest. Okay, so essentially, but with this logic, each of these points now are associated with a specific direction, right? In this case, latitude is associated with the north. This is associated with the south. This is associated with the east. This is associated with the south, and this is associated with the west, right? And the reason for this is these coordinates, these points will make up the perimeter for our city, so that we have this perimeter, and then using an algorithm, we can just check if a specific point is within these perimeters or outside these perimeters. Okay, and that's what we're doing here. So we're first getting the bounds, okay, and we're getting that from our cache again. This is why I have the utility function, because remember I used this before as well. Now there isn't a cache bounds, so again this is a cache miss situation. We're gonna just fetch those bounds from the API, and this is the JSON destructuring to get to this place, right? And we just need to deserialize the JSON because the memcache does not support JSON natively, and then we're just going to serialize it again later on. Serialize just means we're going to decode and encode it into a JSON format. So here we're just decoding or deserializing it into a stringify or a string. Alright, and so that's what we're doing. We're just calling the API and then setting it to the cache. And so now, pretend I make a request again, I'll have that cache, and this cache actually will be used by any user as well, not only you, right? Because it's specific to a city, and many users can be in the same city, and that's the reason why the cache bounds is actually going to be 30 days, which is the longest memcache offers. And the reason why it even has an expiration, it could live forever, but the reason why it has it is bounds do update time to time. It can happen, so just to avoid stale data, I'm gonna have an expiration. All right, but anyways, one thing I'm gonna do actually is I don't need this to be in a string. Okay, perfect. But anyways, we're gonna check for that bounds. All right, and this time we're gonna have a cache hit. All right, so that means we're gonna avoid this process. We're just gonna use our cache, and since we have that cache now, right, the cache bounds, what we can do is we can use this logic over here, which I'm going to explain what this logic does tomorrow, but it essentially just checks if a coordinate is within those perimeters. All right, it's very simple, as you can see, and it's pretty simple to understand as well. Tomorrow, check it out. And then essentially, because this is using comparison operators, it will return a Boolean value, right? As you can see over here with TypeScript, it's letting me know that. And essentially what I'm doing is I'm just putting in my parameters, and I get a Boolean value which will tell me if the coordinate is within that specific perimeter, which we are getting based off of the city. So if your coordinate is within that perimeter, you just return that city that you got from over here from caching it. Or if you're not within that bounds, that means you moved cities, so we need to update your cache, and we can do that here as well. So this way we're avoiding stale data by having this functionality, you know, so that we always have the most updated city in your current location. And yeah, so yeah, this way we're able to you know, leverage the power of caching while still having the most updated information for your specific value, all right, for your city. Okay, so this is it from me, and I'm going to move on to the AI microservice now and updating posts. So this is Hemant, and this has been my TrashFi update.